Hello guys, in today's video we are going to learn GNN, Graph Neural Network. So first point, GNN is a deep learning model designed to work on graph structured data. What is a GNN? GNN stands for basically Graph Neural Network. It's a type of deep learning model. But unlike usual neural network that works on images or text, but GNN are designed to work with graph structured data. The data there is connected like a network. A graph contains nodes and edges. Next, let's understand what's a graph. A graph is made up of nodes, which are just points representing things, and edges, which are connected between those points. For example, in social media network, each person is a node and their friendship is an edge. Third point, unlike CNN or RNN, GNN understand relationship between data points. Unlike CNN, which works with images, and RNN, which work with sequences. But GNN are specially because they can understand the relationship between data points. That means it does not just look at individual points, it also looks at how they are connected and understanding the deeply concept. Fourth point, it captures both local and nearby global informations. A GNN learns in two ways. First, it gathers local information from nearby nodes, like talking to your close friends. Then it is also understand global information from the whole graph, which gives it a bigger picture of the network. Fifth point is used when data is connected, relational or network like. You use GNN when the data is all about connections, for example, road networks for Google Maps, or recommendation system like Netflix, suggestion movies, or even analysis molecules in chemistry. Anywhere stuff is linked together, GNN works best. These all are the GNN introduction. Make solid predictions like what label a node will have, what type of connection and edges is are, even classify the entire graph, such useful in tons of real world tasks. Let's see the picture. The picture shows the graph where each blue circle is a node, basically an item or a point in the data. The blank line connecting them are called edges, which represent relationship or links between the nodes. GNN learns by using these nodes connections for understanding how each node is related to other throughout these edges. The second image shows how graph data like people connected in social network. It gives us an input. Each person is a node and the lines between them shows how they are connected. The neural network in the middle process these connections and learn patterns from the graph. It understands how each person is related to others and how information follows throughout the network. Finally, the model produces an output such as predictions or classification based on the graph structures. Next, nodes share information with neighbors throughout message passing. So guys, basically in a GNN, each node kind of talks to the nodes around it. This whole chatting process is called message passing, where nodes share whatever information they have with their neighbors. Second point, each node collects features from connected nodes. Then what happens is every node collects all the info coming from those connected nodes. You can imagine it like asking your friends, hey, what's going on? And gathering the all information from your friend. That's point it's there. Third point, updates node embeddings based on neighbor information. After collecting that, the GNN updates the node's own understanding, which we call the node embedding. So the node becomes smarter because it learns from the people or nodes around it. Fourth point, after multiple passes, nodes understand the whole graph context. And when this happens again and again for multiple rounds, the node does not just know its close neighbors. It slowly understands the whole network, like getting the full picture. Fifth point. These helps predict node label, edge labels, or entire graph outputs. And because of this, the GNN can make solid predictions like what label a node will have, what type of connection and edges is are, even classify the entire graph. Such useful in tons of real world tasks. Next, types of GNN models. First one, GCN, Graph Convolutional Network. GCN is basically the CNN version but for the graphs. It grabs info from nearby nodes and mixes it nicely, like blending everything smoothly. So each node gets a clean, simple idea what happening around it. Second point, GAT, Graph Attention Network. GAT is a smart because it uses attention. It decides which neighbors are actual matters instead of listening to everyone. It listens more than the important ones. So the node learns is a more forced and intelligent way. Third point, GraphSage. GraphSage is a made for huge network where you can't load everything. It just picks a few neighbors, samples them, and learn from small groups. This makes it super fast and perfect for big social network style data. Fourth point, GGNN, Gated Graph Neural Network. GGNN works kind of like a GRU inside a graph. It has gated to control information. It keeps some info, forgot some, and updates step by step. Great for graphs where things change over times or need multiple message passes. That's all about the GNN types. Application of GNN, social network. It's like a friend recommendation, community detection. Social media user GNN likes idea to understand who is connected to whom. It recommends friends and groups by studying your network pattern. Second one, fraud detection, spotting unusual transaction pattern. Banks check how money usually moves in a network of accounts. If one account behaves differently, the system quickly flags it as possible fraud. Traffic and navigation prediction. Road congestion. Roads and junctions from a graph and models learns how traffic flows between them. This helps apps predict jams and suggest fast routes. It can be used to time saving and avoid traffic jam problems. Healthcare, protein structure prediction and drug discovery. Proteins act like graphs with connected atoms and models learn the shapes. This helps scientists discover new medicines faster. E-commerce, personalized recommendations based on user connections. Shopping platform study user items network to see who buys what. Then they recommended products based on similar user interest. Advantages of GNN, learns relationship. GNN actually understand how data points are connected, not just the futures. CNNs or RNNs cannot do this because they only work on fixed grids and sequences. Handle complex structures. GNN are perfect for any data that looks like a network. Social media, molecules, traffic routes, like that. They can learn pattern even when the structure is too messy and very big problems. Third point, captures local plus global information. GNN first learns from nearby neighborings, then from the whole graphs. So it understands small details and the big picture together. Fourth point, highly accurate in network tasks. In tasks like recommendations, fraud detection, or predicting missing links, JNN performs extremely well. They use relationship pattern to boost your accuracy. Fifth point, scalable to large graphs. Model like GraphSage helps JNNs works with millions of nodes. They sample and learn effectively without slow. That's all about Okay, guys, let's see the example. Imagine a social media platform where every user is a node and the friendships or follow links between them are edges. Each user has different feature like their age, interest and the type of post they are like and how active they are. In a GNN, information flows between connected users throughout a process called message passing. This helps every user learn from the behavior of the friends. Over time, the GNN understands patterns like who is likely to like, share, or comments on the post based on the similar user. Using this learned knowledge, the platform can give better recommendation, shows trending posts, and even suggest a new friends more accurately. Okay, look at the picture. Bob and Alice are just two normal users watching movies. Bob watches Interstellar and Inception, and Alice watches Titanic. Now, these movies are connected to actors and directors. For example, Leonardo acted in Inception and Titanic, and James Cameron directed Titanic and also made Avatar. Because of these connections of the system understand who Bob's like movies with the actor or director. So the platform says if you like those, you might also like Avatar and Blood Diamonds since they share similar actors, director or genres. This is how recommendation system works. They follow the connection just like a map or suggests movies you all probably enjoyed.